Hello, class. We're going to go on to section 8.1, chapter 8. Now, in chapter 8, we switch over from doing descriptive statistics, which was all the earlier chapters, and then we now are going to start talking about inferential statistics. Okay? Descriptive statistics was talking about what distribution it is, how to calculate probabilities, not only that, organizing your data. We did a lot of that in chapter 2 with charts and graphs and whatnot. Descriptive statistics tell us how to describe our data. Now, inferential statistics is used to answer questions about the population that might not be known. Okay, and this is one of the things that we're going to do to help us figure out the population parameters. We're going to construct confidence intervals. Okay, so let's go ahead and talk about exactly what a confidence interval is. You've heard me use this example before in the past. What if we wanted to know the average age of CLC students? Okay? Now, I have no idea what the average age of CLC students is. However, what I can do is I can take a sample of size n, okay? Whatever size I want. And then what I'm going to do is after I find that get that sample, I'm going to find x bar. Remember that this is the sample mean. And what I'm going to say, because of the central limit theorem, the averages, the means, if I keep taking samples of size n, the average of those samples form a normal distribution. Okay, that's what we talked about in chapter 7. So what I'm going to say is that x bar is approximately the same thing as our population mean mu. Okay, it's just an approximation, and in fact, we have a name for this. X bar is called a point estimate. So it's called a point estimate, meaning it may not be the actual mean, but we have some value here that estimates about where the mean is. Okay? Now, this is a starting point to estimate the population parameter. Okay, this is where we're going to start. You have to either be told this value, or if they tell you your sample size or give you data and stuff like that, you can find it yourself. But usually it's told to you. Okay. Now, after you are told, or you have to find the sample mean as your point estimate, what you have to do is you have to calculate your margin of error. And we're going to call our margin of error E, big E. Now, here's the difference in how we're going to go about this. Calculating our margin of error. Depending if we know the population standard deviation or not, we're going to calculate this a little bit differently. And in section 8.4, we're going to talk about proportions, okay? 8.2 and 8.3 talk about confidence intervals for the mean. And 8.4 talks about confidence intervals for proportions. And the formula for each one is different. Now, we are going to go into chapter 11 because we do talk about confidence intervals for the standard deviation. The process is slightly different, so what I'm describing now is only for chapter 8. So, depending on what distribution we're using, we're going to calculate this E differently. And then what you're going to do is, if we're talking about a point estimate for the mean, here's going to be your upper bound. Your upper bound is going to be x bar, or when we get to 8.4, it's going to be p hat, the point estimate for a proportion. So in this case, the upper bound is x bar plus your error, and your lower bound is x bar minus your error. So this is just a number plus a number. You're going to get an upper value. This is a number minus a number. You're going to get a lower value. And what's going to happen is you're going to make a range of numbers, which is x bar, not plus here, x bar minus your error, all the way to x bar plus your error. This is an interval, a range of numbers. This is the smallest number in the range. This is the largest number in the range, okay? So what a confidence interval is telling us is that after we gather our point estimate, we calculate our error. Now, our actual population average should be somewhere between these two numbers, okay? Now we have to talk about confidence level here, okay? That plays an important role, especially when calculating E and interpreting what this confidence interval actually means. Okay, so the idea of a confidence level is, you'll see when you read the problems, they'll tell you what the confidence level is. Some most widely used is 90%, so confidence level equals 90%. Sometimes you'll see a confidence level of 95, that's another common one. Confidence level of 99%, that's another common one. Okay, so, I mean, we can make the confidence level whatever we want. Now, what this confidence level is, it's our certainty in our results, okay? When we find a confidence interval that is x bar minus your error, comma, x bar plus your error, and it has some specified level of confidence, say we are doing a 95% confidence level here, okay? Let's say, remember when we did this, we had a sample size of size n, okay? Now, according to the central limit theorem, if we keep taking samples of size n, our means will form a normal distribution, okay? Now we use a mean to make a point estimate. We calculate some error, which is dependent on this number, but we calculate some error and we make an interval. Now what we would say is, if we're using a 95% confidence level, if we were to construct confidence interval over and over and over and over and over, okay, keeping the same size n. So we pull one sample, we calculate its x bar, it has some point estimate mean, we calculate its error, we make a confidence interval, we do it again for a second sample, a third sample, so we are 95% confident means 95% of the confidence intervals that we make will contain the true population average mu, okay? So if we repeat this process over and over and over, constructing confidence intervals in the same exact way every single time, using the same error formula, of course using different x bars because every sample is going to have its own sample mean. We keep the sample size n the same and we keep the confidence level the same. 95% of those confidence intervals that we construct will contain the true population mean. Okay? That's what a confidence level is doing. You're attaching a certainty onto your interval. Another way of saying it, you are 95%, pretty much layman's terms, relaxed definitions here, you are 95% sure that this interval contains the true population average. We're dealing with means here, so it's going to be average. Okay, so that's the idea behind confidence intervals. If we don't know the population parameter, whether it be the mean, the population proportion, or population standard deviation, we can get a range of numbers where it is likely to be. So it gives us a good place to look, to start looking. Okay. Now, in the next couple of sections, we're going to go through exactly how to calculate these confidence intervals. Now, the procedure between them is very much the same. If you know the procedure, you're going to be good. The hard part here is determining what distribution you are using. Are you using the Z distribution or are you using the T distribution, which we'll talk about in the next videos?